I was thinking you were talking about rational expressions. Yeah. Okay, good. All right, I'm just going to start with page 2. Okay.
Okay.
So factor completely. Stop me if I'm going too fast, or if you have any questions for me. This first one here, notice it's a difference of perfect cubes, right? 27 is 3 cubed, right? So do you remember this formula? It's called, sometimes they refer to it as SOAP.
Yeah.
If you have a sum or a difference of perfect cubes, then that turns into the same sign, the opposite sign, and always positive sign. So the same sign, the opposite sign, and always positive. Okay. And then it's going to be A is going here and B is going here. A squared goes in the first place, B squared goes in the last place, and A times B goes in the middle. That's how that factors.
Okay.
Okay. So this factors into, notice what I have. I have X being cubed and I have 3 being cubed. So this is like your A and this is like your B.
Yeah.
All right. So the signs are going to be negative, positive, positive. See how I got put the signs there?
Mm-hmm.
Negative, because see, it's the bottom one. So it's the same, it's the opposite, and then it's always positive. Same, which is negative, opposite, which is positive, and always positive at the end.
Okay.
Now I take those A, B, and C and I just write them in. A here, B here. Sorry, not A and B. My A is X, right? And my B is 3. So A squared goes here, B squared, which is 9, goes there, and A times B goes in the middle.
Mm-hmm.
Okay.
Yeah.
And then if you actually multiply that out, you would see that it actually does multiply out and just give you X cubed minus 27. Okay, this problem, number 8, is more of a factor by grouping. So this is a grouping problem that you have to do. So you'll notice that there's there's 4 terms, and you can kind of see they have a kind of a pattern to them. Do you notice that for these first 2 terms, I can take an X squared out? And if I do, I'll be left with a 2X and a minus 3.
Mm-hmm.
Got it? And for this other one, I actually can't take anything out, but I'm going to put them in parentheses anyway. So you'll see, and I'm going to put a 1. I'm going to say that I took a 1 out. Just makes it a little bit easier to visualize what I'm doing next. So now what I'm going to do is take out, see how I have 2 terms now? I've got this term and this term.
Mm-hmm.
And so I can take, those 2 terms have a common factor. See how they have a factor of 2X minus 3? Both of them have a factor of 2X minus 3. So I'm taking that out of this term and I'm taking it out of this term. If I take it out, that means I'm going to have it in front. And what am I going to have left over? Well, here, what will be left over if I take this out of it? What's going to be left over?
Just X squared.
Good. And what's going to be left over in this term if I take an 2X minus 3 out?
1.
You see why I put the 1 there?
Yeah.
That's why I did that, so that you can see it better. Now, if this had been a negative 1, I could factor it even more, because then there's that difference of perfect squares thing you can do. But this is not negative 1, it's a positive 1. So I can't factor this anymore, and I'm just done. There's my answer. Okay?
Yeah.
Good? Questions about that?
No, that was good.
Okay. This is different. This is where you're going to have to do some factoring, but then you're going to want to cancel out common factors on the top and the bottom. So first of all, let's just do a similar type of a problem over to the right. You know, like if I had, I don't know, A times B over C times D times A, I'm sorry, B times C over A times E, and then this was divided by, and I have like maybe, I don't know, a C and an E here and a squared up there. Do you know how to do that problem?
I don't know.
So the first step is take this and turn it into a multiplication. So, and the way you turn that into multiplication is you flip it. Dividing by a fraction, see how I'm dividing by a fraction, is the same as multiplying by the reciprocal. So I'm flipping the top and the bottom. And furthermore, I can just leave everything else on the top. I can basically I can make it one big fraction bar like that on the top, and on the bottom is just all the things on the bottom. They're just having a good time on the bottom. And now all I have to do is cancel out common factors in the top and the bottom. So you can see that I can cancel out an A here with an A here. I can cancel a C with a C here. I can cancel a E with the E up here. And that's all I can do. So I'm left with a B times a B, which is B squared, a C on the top, which is C, and I've got an A squared on the bottom and a D on the bottom. So that would be my answer. Okay, so I'm showing you that because now we're going to do that same thing for this problem over here. The difference is we have to factor all of these things, because right now they're not factors, they're terms.
Yeah.
Right? So I can't cancel this x squared with this x squared because those are not factors in the top. See how these are all being multiplied to the right?
Yeah.
These things are just being multiplied or divided. But these things, we've got things being added and subtracted. But if I could turn those into factors, then I can just apply this same thing that I just showed you. And in fact, that's exactly what we're going to do. So we're going to factor out an x on this first one. That will be left with an x squared minus 25. In fact, now I see, oh, wait, I can factor this even more. I can factor x squared minus 25 into x plus 5 and x minus 5. That's that difference of squares thing I was talking about on the last page.
Mm-hmm.
Okay, so those are all the factors. See how I turn that?
Yeah.
I turn that binomial, two terms, into a three factors. Factors are much better to work with typically than terms, because you can cancel factors, you can't cancel terms. What factors out of this next one over here to the right? What factors out of that?
The 2x squared would be it would be it'd be 2 times x
Squared minus 1, but what can I do with x squared minus 1?
You can do x plus 1, x minus 1.
Perfect, good job. So that's what that is. Okay, and how does this one factor over here to the right, staying on the top? How does that factor?
It'd be x times x plus 5.
Good. How about the bottom? How does that factor?
That would be,
I'll just do it. 7 and x plus 1.
okay.
Right? How does
Yeah.
this one factor here on the bottom?
X times x minus 6.
Nope. So this is going to have to be where what multiplies to 5 and adds to -6.
Oh,
-5 and -1.
yeah.
You get that?
Yeah.
That's the more standard factoring, that little riddle I like to say. What multiplies to this, if the leading coefficient here is 1, what multiplies to this and adds to this? And those are the two things that you put here and here. Okay, got it?
Yeah.
Okay, so we've done that, but now let's go. So now look, we've got a bunch of factors. Instead of terms, I have a bunch of factors. 1, 2, 3, 4, 5, 6 on the top, plus, remember, this is going to flip, right? As the division.
Yep.
That's going to flip. So let's go ahead and write this big thing out before we do anything else. So on the top, I'm going to have an x. I'm going to have x plus 5 and x minus 5. I'm going to have a 2. I'll put the 2 in front. And I'm going to have an x plus 1 and an x minus 1. And And then these are going to jump to the top. I'm going to have a 7, so I'll put that in the top, in the front. I like the numbers in the front. 7 times 2, and I'm going to have an x plus 1. So those are all the numbers, all the factors that are on the top. Okay. Now the factors on the bottom, I have a 4 x squared. I have an x minus 5 and an x minus 1. And remember, these flip, right? So that's going to be on the bottom. So I have another x, and I have an x plus 5 on the bottom. Okay.
Yeah.
So now let's just cancel what we can cancel. Okay, notice what I can do now. I can cancel because now I have a bunch of factors. See how these are just a bunch of things being multiplied together? Just like these over here to the right. I got a bunch of factors that are being multiplied, so I can cancel factors out. So I'm going to take the x minus 5 out. I'm going to take the x minus 1 out. I'm going to take an x out.
Yeah.
I could have also taken it from here if I wanted to, but I might as well just take it from that single x sitting there. What else can I take out? Oh, another x plus 5. I'll take an x plus 5 out. And I think that's it. Right? So now let's see what we have left, and let's just write out what we have left. So my answer is going to be 7. Oops, sorry, I'm not done. What can I do with 4 and 2?
You can, wait, would you divide it?
Yeah, I can cancel a 2 out, right?
Yeah.
So it just leaves me with the 2 in the bottom. So here we go. On the top, I have a 7. I have x plus 1 squared. That's all I have on the top. And on the bottom, I have a 2, and I have an x squared. So that's my answer. Now, you might also have to say something like x cannot equal, x does not equal, and you look at what you originally had and make sure that you're not dividing anything by 0, right? So I don't know if your teacher wants you to say this or not, but x really can't equal plus or minus 5 or 0 or 1.
Yeah.
I don't know if your teacher cares about that, if they care about you writing that, but in theoretically speaking, you should write that because you just simplified that expression and you canceled a bunch of stuff out. But originally, you weren't allowed to plug in any of these numbers, any of these 4 numbers up into this, because then that would have given you a 0 in the denominator in those cases.
Yeah. Okay.
I don't know if I have to include -1 as well, because technically -1 would give you a 0 here, and that would make that undefined. So I think maybe you should also say -1. Okay, good.
Yep.
Can I move on?
Uh-huh.
Okay, I'm gonna do this one a little bit faster. You see how I did that on the last one? So now we're doing that same thing. We're factoring these things and canceling. So let's factor this top thing. Let's try grouping first. If I take an x squared out, I'll have a 3x and a 1 left. And if I take a 4 out, a -4, sorry, I'll have a 3x plus 1. Hey, how about that? Notice how I have a 3x plus 1 here and here, so that can come out. So 3x plus 1 comes out, and I'm left with x squared minus 4. Now what can I do with x squared minus 4?
You can simplify it.
Yeah, that's a difference of perfect squares, right? X plus 2, x minus 2. So this is really just that. Okay?
Yep.
On the bottom, I take an x squared out, left with an x minus 3. On the top over here, I take an x out, and I'm left with an x cubed minus 27. Hey, didn't I just do x cubed minus 27? I sure did. It was one of those soap things, right? So it's the same, opposite, always positive, and that was x and 3. So I put x and 3 here. I put x squared and 3 squared here, and I put 3x here. I know I did that fast, but go back, watch the video if you're not sure. This one, a little bit trickier. I'm going to do a little guess and check here. I'm going to take a 3x out and an x out, and I'm going to put a 2 here and a 1 here. because I'm pretty good at guessing and checking, and I can see that 3x times 2 is going to give me 6x plus 1x, which is your 7x, which gives you that middle term. Got it?
Yep.
So I knew this had to break up into 3x and x, and I knew this had to be either 2 and 1 or -2 and -1, and I just kind of guessed and checked until I got it right. Okay, so now we can cancel out common factors. Notice that I have an x squared and an x here, so what can I cancel out?
You can cancel out.
Basically one of them, right? One of the x's.
Yep.
So I'll have an x left on the bottom. I have an x -3 and an x -3, so I cancel those out. I have a 3x plus 1 and a 3x plus 1 on the top, so I cancel those out. I have an x plus 2 and an x plus 2, so I cancel those out. So what's left in the bottom?
Nothing.
Notice I've got everything. I cancel everything but one of the x's.
Yeah.
Do you see it?
Yeah.
And in the top, what do I have left? X
X
minus 2
and then x squared plus 3x minus 9 or plus 9
plus 3x plus 9. Right?
Yep.
So there's your answer. And again, x cannot equal -2. It can't equal -1/3. It can't equal 3, and it can't equal 0, because those are all the things that would have given you a 0 in the denominator originally.
Yep.
Which you can't see anymore because they canceled them out. So that's why you write that domain restriction on there.
Okay.
Good?
Yep.
All right, this is a different beast. For this one, yeah, I'm going to just do this all over here in the white space. Okay, so this one, here's what you're going to do. Now, there's a couple ways you can do these problems. What I like to do is called clearing the fraction. So here's the trick that I would like to teach you. Now, you could do it a different way, and I can show you the other way if this is confusing. But here's what I like to do. Anytime you see a compound fraction like this, where you have fractions inside of fractions, multiply the top and the bottom by the least common denominator of all your fractions. So here's your denominators. What's the least common denominator between these three things? It's m-1 and 25.
1.
You understand that? I'm going to multiply it by m-1 and 25. And I'm going to do that on the top and the bottom. So it's basically, I'm like taking this fraction and I'm multiplying it by the number 1 in the form of 25 times m-1 over 25 times m-1. You understand that?
Yeah.
Okay. I don't know if your teacher taught you this. So now what will happen when I multiply this in here? What's going to happen? What's going to cancel out when I multiply this to the top here?
The m-1.
Do you see how the m-1 cancels out? And you're just going to get 16 times 25 on the top?
Yeah.
Do you see that?
Yeah.
Okay. And on the bottom, when I multiply this to this first term, what's going to cancel out?
The
25 and the 5, right?
Yeah.
So you're going to be left with 5 times m-1 times 16. So this is just going to be 16 times 5 times m-1. That's what you'll have on that term. Okay. And what's going to happen when I multiply this here?
It'll cancel the 25.
The 25s cancel out, and you're just left with -16 times m-1. So you see how I turned that complex fraction into just a regular fraction?
Yeah.
And that's what multiplying by the least common denominator will do. Okay. So now I'm going to actually, to be even more clear, now what I'm going to do is I'm going to factor out. You see how I can factor out now a 16 and an m-1 from both of these?
Yes.
Actually, the m-1 factoring that out won't do anything, because see how I don't have a 16 on the, see how the factors in the top are just 16 and 25?
Yeah.
But the 16, basically I can factor a 16 out of the bottom
Uh-huh.
and be left with 5m minus 1 minus m minus 1. See how I factored out a 16? And now I can cancel out those 16s because now this is a factor in the denominator and it's a factor in the numerator. So I cancel them out now.
Okay.
See ya. So my answer is just, now watch this. This is 5m minus 1 minus 1m minus 1. If you have 5 of something minus 1 of something, how many of that something do you have left?
4.
4. So I really have 4 m minus 1s on the bottom. And remember, I just have 25 on the top.
Mm-hmm.
So that's your answer.
Okay, yeah.
Okay?
Yeah.
That's one way to do it. That's the way I would do it. Another way to do it, which you're welcome to do it this way, but I don't know how your teacher taught it to you, but another way to do it is to get common denominators in the bottom. And then so that's method 1. Here's method 2. 16 over m minus 1, which in this case, this method 2 is not really too bad to do, but I still like clearing the fractions. Whoops, 25. So the least common denominator on the bottom, if I want to add those together, is 25. So I have to multiply this by 5 over 5, right? What's 5 times 16? Well, let's just write 5 times 16. So that's 5 times 16 over 25 minus 16 over 25. That's the bottom.
Okay.
All over 16 over m minus 1. That's on the top. So my numerator is this. My denominator is going to be, let's do that little trick I just showed you. If I have 5 16ths minus 1 16, how many 16s do I have?
4 16ths.
Very good. So I actually prefer just to think of it like that. So I have 4 times 16 over 25.
Mm-hmm.
Got it?
Yeah.
And now, how do I divide a fraction by a fraction? What do I do when I'm dividing a fraction by another fraction? Do you remember?
You can do the reciprocal.
Yeah, you multiply by the reciprocal. So this is going to equal, watch this, 16 over m minus 1, that's the numerator, times, now I'm flipping the bottom one, 25 over 4 times 16.
Okay.
And you see the value of not multiplying the 4 and the 16 out? You see what I can do now?
Yeah.
Can you see now I can just cancel those out?
Yep.
And so my answer again is 25 over 4 times m minus 1.
Yeah.
2 ways to the same answer. You pick. Either one's fine with me. For this one, we have 3 minutes. I bet I can get this done. Okay. For this one, I'm going to do that trick I just told you. It's called clearing the fraction. So what am I going to multiply by? What am I going to multiply the bottom and the top by?
3. Wait.
I'm going to multiply by the least common denominator, which is this and this multiplied together.
Okay.
Okay. So I'm going to multiply the top and the bottom by x minus 1 and x plus 4. X minus 1 and x plus 4. This is kind of an ugly problem. I'm not sure how well this is going to work out. Well, let's do it. So when I multiply this in here, what cancels out?
The x plus 4. Oh, wait.
The x minus 1 cancels out, and you're just left with an x plus 4, right?
Yeah.
When I multiply this into here, I'm going to color code this for you. When I multiply this whole thing into here, into the x, nothing cancels out, right? So it's just x times x minus 1 and x plus 4. And when I multiply that into here, nothing cancels out. It's just 3 times x minus 1 and x plus 4.
Mm-hmm.
Okay?
Yeah.
That's the top. On the bottom, when I multiply it, this into here, again, nothing cancels out. So it's just x times x minus 1 and x plus 4. When I multiply it into here, nothing cancels out. It's just minus 3 times x minus 1 and x plus 4. And when I multiply it into here, the x plus 4 cancels out, and you just have plus x minus 1.
Okay, yeah.
That's a lot of mess. Trying to think if there's an easier way to have done this problem, because this is like a tricky. Kind of a tricky part. I almost feel like there's a trick to this one that we could have found, because you see I have an x plus 3 here and an x minus 3 here.
Oh yeah.
I almost feel like that might relate to it somehow. So I'm looking at this. How can I simplify that? And I'm thinking, well, these are terms, not factors. So there's not really much I can do except just multiply it out, maybe. So let's just multiply it out. So this is going to be x squared. When I multiply these things together, it's going to be x squared plus 3x minus 4, right?
Mm-hmm.
That's what that's going to be. So it's x times that, and it's 3 times that, x squared plus 3x minus 4. So that would really be x cubed plus 3x squared. I'm multiplying the x in. Plus 3x squared plus 6x minus 12. And then you still have the x plus 4 up there. And so then you would add like terms on the top, which is a pain in the butt. And then the bottom, whoops, I don't know where that came from. On the bottom, I'm going to have x squared plus 3x minus 4 and x minus x squared plus 3x minus 4 times 3 plus x minus 1. So I'm distributing now. X cubed plus 3x squared minus 4x minus 3x squared minus 9x plus 12, careful with the signs, plus x minus 1. Okay, so now I'm going to clean up all of that stuff. I'll write this way down here. So adding like terms together, I have x cubed. Let's look at the x squared terms. I have 3x squared plus another 3x squared, which is
3x.
6x squared. I've got 1x minus 4x's is negative 3, plus 6, which is positive 3. Right? So that's plus 3x. And then I have 4 minus 12. Are there any other constants? I don't think so. 4 minus 12 is
8.
Negative 8.
Yeah.
Okay, there's my numerator. Let's do that same thing for the denominator. I've got x cubed, that's it. I've got 3x squared minus 3x squared. Oh, that's nice. They cancel out. So I've got no x squareds, right?
Yep.
I've got negative 4x minus 9x, which is negative 13x plus 1x, which is negative 12x.
Mm-hmm.
And then I have 12 minus 1, which is 11. And that's your answer.
Okay, yep.
Do you have the answer key for that?
Yeah, I do.
Can you check if that's the answer, or if they want us to factor it more? Because I can't see how that can factor more.
1 second. Let me see. Unit 2A. Let me find what page.
So you can choose whichever way you want to do that problem, but that's called clearing the fractions. I'll show you the other way you can do it. The other way you can do it is you can multiply, you can get common denominators on the bottom and the top, which means you would multiply this by x plus 4 on the top and the bottom.
Uh-huh.
And then you'd multiply this by x plus 4 on the top and the bottom. And you would multiply this by x minus 1 on the top and the bottom. And you would get, if you did that, I'll do it real quick so you can see how it gives you the same answer. You would get 1 over x minus 1, there's my first term, plus x squared. Oops, sorry, I meant to erase that. I'm trying to think, can I multiply that straight, that whole thing? Yeah, I guess I could. So this might actually be a little bit faster. You would get x squared plus 2x minus 3 all over x minus 1. So that's your top, all over. And then on the bottom, you'd have x squared plus x minus 12 all over x plus 4 plus 1 over x plus 4. And that would give you, on the top, you would have x squared plus 2x minus 2 over x minus 1. That's the top. And on the bottom, see how I'm getting common denominators now? See how I have the common denominators, so I'm just adding them together.
Yeah.
At the bottom, you'd have x squared plus x minus 11 all over x plus 4.
Okay. Yeah.
And now you flip and multiply. So now I would take this and I would flip and multiply it by that. And I would get, let's see if it factors anymore though. Does x squared plus 2x?
This is what he did because his answer was x squared plus 2x minus 2 times x plus 4, and then x minus 1 times x squared plus x minus 11.
Yeah, and so he would, so then your answer would be x squared plus 2x minus 2 times x plus 4, those are on the top, all over x minus 1 times x squared plus x minus 11 on the bottom. But none of those cancel.
Okay. Yeah.
And I bet if you multiplied those out, I bet that would be this right here.
Yeah. Yeah, it is.
So either one is probably acceptable, but this example probably was easier to do this way and not clearing the fraction, to be honest with you. I don't know. But a lot of times clearing the fraction is the better way to do it. That was kind of a unique type of a problem that you had to do a little bit of extra thinking with it. But anyway, hopefully that helps. You feel good about what you got going on?
Yep.